This week we will be completing the acid-base analysis by potentiometric titration. The goals for this week's lab are to draw and label a titration curve and identify an unknown using potentiometric titration. After graphing your titration curve, you will be able to identify your unknown by determining your molar mass, pKa, and melting point. You will be titrating an unknown monoprotic organic acid. When the weak acid is dissolved in water, H3O+ and A- is produced. As you slowly add base, the NaOH will completely react with the H3O+ to form Na+ and water. When adding these two reactions together, we see that when a weak acid reacts with a strong base, a salt and water are produced. The characteristics of this particular acid-base reaction is that it is a fast reaction, it has 1-to-1 stoichiometry, and the endpoint is easily determined. You will first need to complete a crude titration to ensure that a reasonable quantity of acid is analyzed in the potentiometric titration. This crude titration is only completed once and is used to determine how much weak acid will be needed to reach an endpoint around 18 to 20 milliliters. Your first step is to weigh out approximately 0.15 grams of your unknown and dissolve in water. Quickly titrate with NaOH until the endpoint is reached. You will not need to use your pH meter at this time. The endpoint can be determined by phenolphthalein indicator. Using your mass of unknown and volume of NaOH added, we can easily determine how much unknown you should use for the potentiometric titration. For example, I found that a crude titration requires 12 milliliters of base to react with 0.15 grams of unknown. If I want to scale this up to 18 to 20 milliliters, I would use this equation. By cross-multiplying and solving for x, I found that I would need 0.238 grams of unknown to react with my 19 milliliters of NaOH. When I begin my potentiometric titration, I will weigh out between 0.225 and 0.25 grams of my unknown. Make sure to record the actual weight that is used. For the potentiometric titration, you will be using a pH meter. All of your pH readings should be rounded to 0.1. Do not allow the stir bar to hit the electrode. Always rinse the electrode with DI water when changing solutions. Have a TA check your setup before titrating. When you are using the burettes, make sure that there are no air bubbles in the tip, and when recording the volume, make sure to read your volume from the lower portion of the meniscus. The electrodes are fragile and can easily be broken. Before starting your titration, make sure that your spinning stir bar does not hit your electrode. Here is an example of how you should rinse your electrode after changing solutions. Make sure to rinse your electrode every time you change solutions. Once you finish your titration, you should have a curve that looks like this. From this curve, you should be able to identify the endpoint, the pKa, and the following points when the concentration of HA is much greater than A-, when the HA is equal to A-, and when the A- is greater than HA. Once you determine the endpoint, you can calculate the molar mass of your unknown. The mass of your weak acid was weighed on the balance. The moles of your weak acid is determined from the amount of NaOH needed to reach the endpoint when the reaction turned pink. Recall that this reaction has 1-to-1 stoichiometry, so if you know the moles of base added, this is equivalent to the moles of acid. To calculate the moles of NaOH, simply multiply the volume of NaOH times the concentration of NaOH. By taking your mass of unknown divided by the moles, you will determine the molar mass of your unknown. Your TA will give you a packet that contains a small amount of your unknown. You will need to make 2 solutions of your unknown, so do not use it all at once. If you run out of unknown, you will have to start the lab over. Make sure to do the full titration curve. After you reach the endpoint, make sure to continue adding and recording an additional 5 to 6 milliliters of NaOH. Do not forget to add phenolphthalein indicator. If you do not add indicator, your solution will never turn pink. Your TA has already standardized the pH meters, so you can ignore this portion in your lab. Make sure that all of your unknown has dissolved before starting your titration. You will be using a magnetic stir plate for this lab. It is also a hot plate, so make sure that you do not turn on the hot plate. If you can not uniquely determine your unknown from the molar mass and pKa, then you will need to do a melting point.